You'll thank yourself later for watching this before your interview. What is ROC? Answer: AUC ROC area under the ROC curve is a single scalar value that summarizes the performance of a binary classifier. It's a measure of how well the classifier can distinguish between positive and negative classes. The value ranges from 0 to 1, where 1 represents perfect classification and 0 represents random guessing. A higher AUC ROC score indicates better performance of the classifier. What does a higher AUC value indicate in the context of classifier performance? Answer: a higher AUC value indicates better discriminatory ability, meaning the classifier is more effective at distinguishing between positive and negative classes. In other words, it is better at correctly identifying instances that belong to each class. This is because AUC ROC evaluates the classifier's performance across all thresholds, providing a comprehensive measure of its ability to balance sensitivity and specificity. A higher AUC value indicates that the classifier is more accurate and reliable in its predictions. What is the role of eigenvalues and eigenvectors in PCA? Answer: eigenvalues and eigenvectors are crucial in PCA because they help identify the principal components. Eigenvalues represent the variance explained by each principal component, with higher values indicating more significant components. Eigenvectors define the direction of the principal components in the feature space. PCA uses these eigenvectors to project the data, retaining the maximum variance while reducing dimensionality. This is why eigenvalues and eigenvectors play a vital role in PCA. How does the random forest algorithm handle overfitting? Answer: the random forest algorithm reduces overfitting by averaging predictions from multiple decision trees, selecting random features for each tree, and using bootstrap aggregation to train trees on different subsets of the dataset. These mechanisms combine to create a robust ensemble model that is less prone to overfitting compared to a single decision tree. What is the role of a learning rate and gradient descent? Answer: the learning rate and gradient descent controls the step size at each iteration of the optimization process. A small learning rate ensures stable convergence but increases computation time, while a large learning rate speeds up convergence but risks overshooting the minima or divergence. An optimal learning rate balances convergence speed and stability, and techniques like learning rate schedules or adaptive optimizers can dynamically adjust the rate. How do you stack up against other learners? MLQs Café lets you find out every quiz you take builds your skills and tracks your growth. Challenge yourself today and see real improvement. Now let's get back to the next question. Explain how support vector machines SVM work. Answer: support vector machines SVM are a type of supervised learning algorithm that finds the best hyperplane to separate classes in a feature space. To do this, SVM maximizes the margin, which is the distance between the hyperplane and the nearest data points from each class. These nearest data points are called support vectors. SVM also uses the kernel trick to map nonlinear data into a high-dimensional space, allowing it to perform linear separation. This makes SVM effective for both linear and nonlinear classification problems. Overall, SVM is a powerful algorithm for finding the best boundary between classes in a dataset. What is the difference between KNN and K-means clustering? Answer: KNN K-nearest neighbors is a supervised learning algorithm used for classification or regression, where it assigns labels based on the majority label of the K-nearest neighbors. On the other hand, K-means clustering is an unsupervised learning algorithm used for clustering, where it groups data into K clusters by minimizing intra-cluster variance. The key difference between the two is that KNN is predictive, while K-means is descriptive. KNN requires a distance metric to find the nearest neighbors, whereas K-means uses a distance metric to assign points to clusters. Additionally, KNN has a lazy training phase, whereas K-means has an iterative training phase to find centroids. What is the difference between batch gradient descent and stochastic gradient descent? Answer: batch gradient descent calculates the gradient of the cost function using the entire dataset before updating the parameters, making it more stable and deterministic but computationally expensive. On the other hand, stochastic gradient descent computes the gradient and updates parameters for each individual data point, making it faster and more suitable for large datasets but with noisy and less stable convergence. What is the difference between a generative and discriminative model? Answer: a generative model is a type of machine learning model that can generate new data points by modeling the joint probability of the input variables. This means it can create new data that is similar to the training data. On the other hand, a discriminative model is a type of machine learning model that focuses solely on decision boundaries, modeling the conditional probability of the output variable given the input variables. This means it is only concerned with making accurate predictions rather than generating new data. Generative models are often used for tasks such as image synthesis and speech generation, while discriminative models are often used for classification tasks. How do you handle imbalanced datasets and classification problems? And so when dealing with imbalanced datasets and classification problems, there are several techniques to handle this issue. One approach is to use resampling techniques, such as oversampling the minority class or undersampling the majority class. Another approach is to use class weights, which assign higher penalties to misclassification of the minority class in the loss function. Data augmentation is also a technique used to generate synthetic data for the minority class. Additionally, some algorithms like XGBoost have built-in parameters to handle class imbalance. It's also important to use evaluation metrics like precision, recall, fun score, and AUC/ROC instead of accuracy to get a more accurate picture of the model's performance. These techniques can help to improve the model's performance on the minority class and overall. What is a variational autoencoder VAE and how do they work? Answer: a variational autoencoder VAE is a type of generative model that uses a neural network to learn a probabilistic representation of the input data. It works by first encoding the input data into a lower-dimensional latent space, and then generating new data samples by sampling from this latent space. The VAE is trained to maximize the likelihood of the input data given the latent variables, which encourages the model to learn a meaningful and interpretable representation of the data. The VAE is also able to reconstruct the original input data from the latent variables, which allows it to be used for tasks such as dimensionality reduction and data compression. Overall, the VAE is a powerful tool for learning complex distributions over data and generating new data samples that are similar to the training data. What is the purpose of an encoder in a generative model? Answer: an encoder, in the context of a generative model, is a component that maps the input data to a latent probability distribution denoted as QZX. This means that the encoder takes in the input data X and outputs a probability distribution over the latent variables C. The purpose of the encoder is to learn a representation of the input data in the latent space, which can then be used to generate new data samples that are similar to the original input data. The encoder is a crucial component in generative models, as it enables the model to learn complex patterns and relationships in the data and generate new data that is coherent and realistic. What is the purpose of introducing randomness by sampling from the learned distribution in latent space? Answer: in latent space, introducing randomness by sampling from the learned distribution helps to introduce variability and uncertainty, which is essential for generating diverse and realistic data. This randomness allows the model to explore different possibilities and create new, unseen data that is still consistent with the learned patterns and relationships. By sampling from the learned distribution, the model can generate a wide range of outputs, making it more flexible and capable of handling complex tasks. This is particularly useful in applications such as data augmentation, where the goal is to create more diverse and robust training data. What is the purpose of a decoder in a neural network, and how does it work? Answer: decoder is a type of neural network layer that takes the output from the encoder, the latent representation, and reconstructs the original input data. In other words, it tries to reverse the process of encoding by mapping the abstract representation back to the original input. This is useful for tasks such as image generation, text-to-image synthesis, and anomaly detection. The decoder works by taking the latent representation and passing it through a series of layers, each of which applies a nonlinear transformation to the input. The output of the decoder is the reconstructed input data, which is compared to the original input to evaluate the quality of the reconstruction. The decoder is trained to minimize the difference between the original and reconstructed input data, which encourages it to learn a meaningful mapping between the latent representation and the input data. What is the purpose of combining reconstruction loss e.g., MSC and callback labeler KL divergence in a loss function? Answer: the purpose of combining reconstruction loss e.g., MSC and callback labeler KL divergence in a loss function is to encourage meaningful latent representations. Reconstruction loss e.g., MSC measures the difference between the original input and the reconstructed input, while callback labeler KL divergence measures the difference between the predicted distribution and the true distribution. By combining these two losses, the model is incentivized to generate latent representations that are not only accurate but also meaningful and interpretable. This helps the model to learn more robust and generalizable representations that can be used for a wide range of tasks. What is entropy in decision trees, and how does it measure the uncertainty in a dataset? Answer: entropy is a measure of impurity or randomness in a dataset. It quantifies the uncertainty in the target variable by calculating the amount of information gained from splitting the dataset. In other words, it measures how well the features in the dataset can be used to predict the target variable. A higher entropy value indicates that the dataset is more random and unpredictable, while a lower entropy value indicates that the dataset is more structured and predictable. This concept is used in decision trees to determine the best feature to split the dataset at each node, with the goal of minimizing entropy and maximizing the purity of the resulting subsets. What is transfer learning? When is it used? Answer: transfer learning is a technique in machine learning where a model trained on one task source domain is fine-tuned or adapted to perform a different but related task target domain. It's used in scenarios where there is a small dataset for the target task, the source and target task share underlying features, or when pre-trained models are available. This approach saves computational resources and time by leveraging pre-trained models, making it a popular choice in areas like NLP and computer vision. How do gradient boosting and XGBoost differ? Answer: gradient boosting is a sequential ensemble method that builds models iteratively, minimizing the residual error by adding weak learners. XGBoost, on the other hand, is an optimized version of gradient boosting that offers advanced features for efficiency and accuracy. Key differences include speed, regularization, handling missing values, and objective functions. XGBoost is faster due to parallel processing and tree pruning, and it includes lin/L2 regularization to prevent overfitting, whereas gradient boosting lacks built-in regularization. Additionally, XGBoost has an inbuilt mechanism to manage missing values and supports a wider range of objective functions. Overall, XGBoost is a more powerful and efficient version of gradient boosting. What is federated learning? Answer: federated learning is a method of training machine learning models where data stays on individual devices such as smartphones or computers, and only the updates to the model are shared with a central server. This approach helps protect sensitive data while still allowing for collaborative training on large datasets. It's like a team effort where everyone contributes their part without sharing their entire dataset. This way, the model can learn from the collective data without compromising individual privacy. Explain Bayesian optimization. Answer: Bayesian optimization is a method used to optimize a function that is difficult or expensive to evaluate. It does this by creating a model of the function called a surrogate model, which is based on the function's behavior at a limited number of points. This model is then used to predict the function's behavior at other points, allowing the algorithm to choose the most promising points to evaluate next. This process is repeated until the desired level of optimization is reached. Bayesian optimization is particularly useful when the function is complex, noisy, or has many local optima, making it difficult to find the global optimum using traditional optimization methods. It is widely used in machine learning, computer vision, and other fields where optimization is a key challenge. How can I build a surrogate model of the objective function? Answer: a surrogate model is an approximation of the original objective function that is easier to evaluate and optimize. To build a surrogate model, you can use a technique such as polynomial regression, radial basis functions, or Gaussian processes. First, you need to collect a set of input-output data points from the original objective function. Then, you can use this data to train a surrogate model, which can be used to approximate the original objective function. This can be useful when the original objective function is expensive to evaluate or has a complex form, making it difficult to optimize directly. The surrogate model can be used to quickly evaluate the objective function and its derivatives, allowing for faster optimization and more efficient exploration of the design space. How can we use the acquisition function, such as expected improvement, to select the next point to evaluate in a Bayesian optimization problem? Answer: the acquisition function is a mathematical formula that helps us decide which point to evaluate next in a Bayesian optimization problem. In expected improvement, we calculate the expected improvement in the objective function value if we were to evaluate a new point. The point with the highest expected improvement is selected as the next point to evaluate. This approach balances exploration and exploitation, allowing us to find the optimal solution efficiently. By using the acquisition function, we can make informed decisions about which points to evaluate next, reducing the number of evaluations required to find the optimal solution. How can we efficiently update a surrogate model with new data in machine learning? Answer: we can update the surrogate model with new data efficiently by using it for hyperparameter tuning in machine learning models. This approach is particularly useful for finding optimal learning rates or tree depths. The surrogate model can handle non-convex, noisy, and expensive to evaluate functions, making it a powerful tool for optimizing complex machine learning models. By updating the surrogate model with new data, we can refine its predictions and improve the overall performance of the machine learning model. What is gradient clipping and how does it prevent exploding gradients in deep learning models? Answer: gradient clipping is a technique used to prevent exploding gradients during backpropagation in deep learning models. When gradients exceed a certain threshold, they are scaled down to keep them within a reasonable range. This helps to stabilize the training process and prevent the gradients from growing too large, which can cause the model to diverge or become unstable. By clipping the gradients, the model can learn more effectively and accurately. What is tokenization in NLP and why is it important? Answer: tokenization in NLP is the process of breaking down text into smaller units, called tokens, such as words, subwords, or sentences. This is important because it allows for the syntactic and semantic processing of text, standardizes input for algorithms, and is essential for tasks like sentiment analysis, machine translation, and text summarization. By splitting text into tokens, NLP models can analyze and understand the meaning and structure of the text more effectively, making it a crucial step in many NLP applications. What is the bag of words BOW model and how does it represent text data? Answer: the bag of words BOW is a text representation model that converts text data into numerical format by counting the occurrences of each word in a document, ignoring grammar and word order. In this model, a vocabulary of unique words is created, and each document is represented as a sparse vector of word frequencies. This means that each document is represented as a list of word counts, where the words are the unique words in the vocabulary and the counts are the number of times each word appears in the document. This representation is often used in natural language processing tasks such as text classification and clustering because it is simple and efficient, but it has limitations such as ignoring context and semantics and resulting in high-dimensional, sparse vectors for large vocabularies. What is word embedding, and how does it differ from one-hot encoding? Answer: word embedding is a technique that represents words as vectors in a high-dimensional space, allowing words with similar meanings to be closer together. This is different from one-hot encoding, which represents words as binary vectors where each word is a unique combination of zeros and ones. Word embedding is more effective because it captures semantic relationships between words, making it useful for tasks like language translation and text classification. In contrast, one-hot encoding is a simple and straightforward method, but it does not capture the nuances of word meanings. What is the purpose of stop word removal in NLP? Answer: stop word removal is a technique used in natural language processing NLP to eliminate common, non-informative words from text data. The purpose of this removal is to reduce noise in the dataset, improve computational efficiency by shrinking the feature space, and enhance the relevance of features in tasks like text classification or clustering. This helps to focus on meaningful content and improve the accuracy of NLP models. What is named entity recognition NER and how does it work? Answer: named entity recognition NER is a natural language processing NLP task that identifies and categorizes named entities in text into predefined categories such as person names, organizations, locations, dates, and numerical values. It works by analyzing the text and recognizing specific words or phrases that match these categories, and then labeling them accordingly. For example, in the sentence "Google was founded in 1998 by Larry Page and Sergey Brin in California," NER would identify Google as an organization, 1998 as a date, Larry Page and Sergey Brin as person names, and California as a location. This technology has many applications, including information retrieval, question answering, and entity linking. What is the difference between TF-IDF and count vectorizer? Answer: count vectorizer is a method that converts text into a matrix of word counts, focusing on the frequency of words in a document. On the other hand, TF-IDF term frequency inverse document frequency is an extension of count vectorizer that weighs word frequency with its importance. df/df takes into account the frequency of a term in a document term frequency and discounts common terms across multiple documents versus document frequency. This makes tf/df superior for text relevance tasks as it emphasizes rarer, more informative words. In summary, tf/df is more effective than count vectorizer in capturing the meaning and relevance of text. How does the transformer architecture revolutionize NLP? Answer: The transformer architecture revolutionizes NLP by introducing self-attention mechanisms, which allow it to process sequences of data in parallel without relying on recurrent or convolution. This enables the model to capture global dependencies in sequences, making it more efficient and effective than traditional recurrent neural networks (RNN) and convolutional neural networks (CNN). As a result, the transformer architecture has become the foundation for many state-of-the-art NLP models, leading to significant advancements in tasks such as text generation, translation, and summarization. What is the difference between a feed-forward neural network and a recurrent neural network (RNN)? Answer: Feed-forward neural network (FNN) is a type of neural network that processes data in a static manner, where the output at a given time step is dependent only on the current input and previous layer activations. On the other hand, a recurrent neural network (RNN) is designed to handle sequential data by introducing loops in the network, allowing it to maintain hidden states and capture temporal dependencies. The main difference is that FNN assume input data is independent, while RNN are designed to process sequences of data, retaining information from previous time steps by hidden states. This makes RNN ideal for tasks where the sequence order is important, such as time series forecasting, natural language processing, and speech recognition. What is the purpose of activation functions in neural networks? Name a few. Answer: Activation functions are used in neural networks to introduce nonlinearity, allowing the model to learn complex patterns in data. This enables the network to approximate any function, making it powerful for tasks such as classification, regression, and object detection. A few common activation functions are sigmoid, ReLU rectified linear unit TAN, and softmax. These functions help the network learn and make predictions by introducing nonlinear relationships between the inputs and outputs. Explain the concept of backpropagation in neural networks. Answer: Backpropagation is a supervised learning algorithm used to optimize the weights of a neural network by minimizing the loss function. It works by propagating the error backwards from the output layer to the input layer, adjusting the weights and biases at each layer to minimize the loss. This process is repeated for each training example, and the algorithm converges when the loss is minimized. In simple terms, backpropagation helps the neural network learn from its mistakes by adjusting its weights and biases to make better predictions. This algorithm is widely used in deep learning applications such as image and speech recognition, natural language processing, and more. What is the purpose of the forward pass in a neural network? Answer: The forward pass is the process of passing input data through a neural network to compute predictions. It is the first step in the training process, where the network takes in input data, performs calculations, and produces output predictions. The forward pass is used to make predictions on new, unseen data, and it is an essential part of the neural network's functionality. During the forward pass, the network's weights and biases are not updated, and the output is solely based on the input data and the network's architecture. The forward pass is often referred to as the forward propagation or forward computation of the neural network. What is the purpose of the loss function in machine learning, and how is it calculated? Answer: The loss function, such as mean-squared error, is used to measure the difference between predicted values and actual outputs. It is calculated by comparing the predicted values with the actual outputs and computing the error. The purpose of the loss function is to quantify the model's performance and guide the training process to minimize the error. The loss function is used to evaluate the model's accuracy and make adjustments to improve its predictions. In other words, the loss function helps the model learn from its mistakes and become more accurate over time. What is the purpose of the backward pass in a neural network, and how is it used to compute the gradient of the loss with respect to each weight? Answer: The backward pass is a process in a neural network where the gradient of the loss with respect to each weight is computed using the chain rule of calculus. This tells us how much each weight contributed to the error. The backward pass is used to compute the gradient of the loss with respect to each weight, which is then used to update the weights during the training process. This helps to minimize the loss and improve the performance of the network. In other words, the backward pass helps to identify which weights need to be adjusted to reduce the error, and by how much. This process is repeated for each layer in the network, allowing the network to learn and adapt to the data. What is the purpose of adjusting the weights in the opposite direction of the gradient using an optimization algorithm like gradient descent? Answer: the purpose of adjusting the weights in the opposite direction of the gradient is to minimize the loss. This is done to optimize the model's performance by reducing the error between the predicted output and the actual output. The gradient descent algorithm calculates the gradient of the loss function with respect to the weights, and then updates the weights in the opposite direction of the gradient to reduce the loss. This process is repeated until the loss is minimized, resulting in the optimal weights for the model. What is a convolutional neural network CNN, and where is it used? Answer: a convolutional neural network CNN is a type of deep learning architecture that is specifically designed to process images and other grid-like data. It's used in many applications where data has spatial correlations, such as image classification, object detection, and semantic segmentation. CNN are commonly used in computer vision, medical imaging, and autonomous vehicles to recognize objects, detect tumors, and detect road signs. How does dropout help in preventing overfitting in deep learning? Answer: dropout is a regularization technique that helps prevent overfitting in deep learning by randomly disabling a percentage of neurons in the network during training. This forces the network to learn more robust features that generalize better to unseen data, rather than relying on any single neuron. As a result, the model's capacity to memorize the training data is reduced, improving its ability to perform well on test data. What are the differences between LSTMs and GRU? Answer: LSTMs and GRU are both types of RNN designed to address the vanishing gradient problem. The main differences between them are their architectures. LSTMs have 3 gates: input gate, forget gate, and output gate, and use the cell state to store long-term dependencies. GRUs, on the other hand, combine the forget and input gates into a single update gate and do not use a separate cell state, relying only on hidden states. This makes GRU simpler and more computationally efficient than LSTMs, but also limits their ability to model more intricate patterns. Overall, LSTMs are more complex and perform better on longer sequences, while GRU are simpler and perform well with shorter sequences. What is transfer learning and deep learning, and why is it effective? Answer: transfer learning is a technique in deep learning where a pre-trained model is used as a starting point for a new task, with only the final layers being retrained on a smaller dataset. This is effective because the pre-trained model has already learned general features that are applicable to many tasks, such as edges, shapes, and textures. By fine-tuning the model on a smaller dataset, the model can adapt to the specific task at hand, leveraging the knowledge gained from the pre-training phase. This approach allows for faster training times and better performance on the new task, especially when the new dataset is small. Why does fine-tuning a model on a target dataset require fewer epochs compared to training a model from scratch? Answer: the model already has learned low-level features such as edges and textures from a large dataset, so it doesn't need to spend as much time learning these basics again. As a result, fine-tuning on the target dataset requires fewer epochs, speeding up the training process. This is because the model can focus on adapting to the specific task and dataset, rather than starting from scratch and learning everything from the beginning. What is the benefit of fine-tuning a model, and how does it improve its performance on smaller datasets? Answer: fine-tuning a model allows it to learn high-level, domain-specific features, which leads to better generalization on smaller datasets. This means that the model can adapt to the specific characteristics of the new dataset and make more accurate predictions, even with limited data. By learning these features, the model becomes more specialized and can perform better on the specific task or problem it's being used for. What is the advantage of using transfer learning for applications with small datasets or rare tasks? Answer: transfer learning is effective for applications with small datasets or rare tasks because it allows the use of large pre-trained models, which mitigates the problem of limited data. This means that even with limited data, the model can still learn and perform well, making it a useful approach for tasks with limited data availability. How can using pre-trained models reduce the computational costs and time required for training deep learning models from scratch? Answer: using pre-trained models can significantly reduce both time and computational costs required for training deep learning models from scratch. This is because pre-trained models have already learned general features and patterns from a large dataset which can be adapted and fine-tuned for a specific task. This approach saves computational resources and time by leveraging the knowledge gained from the pre-training process, allowing the model to focus on learning task-specific features. As a result, fewer labels, images, and computational resources are required, making it a more efficient and cost-effective way to train deep learning models. What is reinforcement learning? Answer: reinforcement learning (RL) is a type of machine learning where an agent learns to make decisions by interacting with an environment. The goal is to maximize a cumulative reward signal over time by taking actions that lead to favorable outcomes. The agent learns through trial and error, receiving feedback in the form of rewards or penalties. It's different from supervised learning, where the agent relies on labeled data and instead relies on its experiences and ability to explore and exploit the environment. The key components of RL include the agent, the environment, states, actions, rewards, and a policy that dictates the agent's actions. What is deep Q learning (DQN)? Answer: deep Q learning (DQN) is a type of reinforcement learning that uses a deep neural network to estimate the Q value function, which helps an agent learn the best actions to take in a given situation. Unlike traditional Q learning, which uses a Q table to store action value pairs, DQN uses a neural network to approximate the Q values, making it suitable for high-dimensional problems like image-based tasks. The algorithm uses experience replay and target networks to stabilize training, and has been successful in playing Atari games directly from raw pixel data. Explain the role of exploration vs exploitation in RL. Answer: in reinforcement learning, exploration refers to the agent's ability to try new actions that might lead to higher long-term rewards, while exploitation is the agent's tendency to choose actions that have already provided high rewards in the past. The balance between these two is crucial. Exploration helps discover new states and actions that may yield better rewards in the future, preventing the agent from getting stuck in suboptimal policies. Exploitation allows the agent to maximize immediate rewards by choosing actions known to be effective. Balancing exploration and exploitation is managed by algorithms like epsilon greedy, where the agent explores randomly with probability epsilon and exploits the best known action with the remaining probability. Explain hyperparameter optimization techniques. Answer: hyperparameter optimization is a crucial step in machine learning as it helps to improve model performance by finding the best combination of hyperparameters. There are several techniques used for hyperparameter optimization, including grid search, random search, Bayesian optimization, genetic algorithms, and gradient-based optimization. Grid search involves testing a predefined set of hyperparameters, while random search randomly samples hyperparameter combinations. Bayesian optimization models the performance of hyperparameters as a probabilistic function and uses this model to select the most promising configurations. Genetic algorithms use a population-based approach, where multiple hyperparameter sets are iteratively evolved through crossover and mutation operations. Gradient-based optimization uses gradients of hyperparameters to optimize their values. Each technique has its own strengths and weaknesses, and the choice of technique depends on the specific problem and available computational resources. By using these techniques, machine learning practitioners can find the optimal hyperparameters for their models and improve their performance.